Hey guys, Sebastian from Madrigal here. This is the fifth part in the video series where we create a Vulkan renderer for the Basis game engine. Be sure to check the previous parts if you haven't to get a good idea of where we are and where we're going. So in the last part we pretty much wrapped our render device, at least for now. So now if we run this and see how far we get, we still crash at the same place as previously, which is in the buffer. But I don't really want to go to buffers yet, because I want to get the whole swap chain render target thing wrapped before I go anywhere else, because it's kind of tied to the render device. There's some special code in here for setting up all that stuff. So let's have a quick look. I could maybe wait a minute. Oh, there we go. Okay. I'm trying to get my remarkable to actually. Now there we go. All right. Now I can draw things for you. Yes. So the way this whole thing with the devices and the render targets work is that you have the device, and you have a render context. Let's call that rend context, like this. The device essentially creates everything, and the device can create a render target like this, and it can create another render target, and let's do one more. And a render target is essentially a way to tell the system that, hey, I want to render into a specific image. So behind each render target there is like a texture, an image in Vulkan terminology. So these are kind of linked like this, right? Then we have the thing called the swap chain, which is called swap chain in both Vulkan and DirectX, and also incidentally Basis terminology. Swap chain is essentially like a chain of images like this, and you essentially go from one to the other. Typically you have 3 if you have triple buffering, and then you go back to the first. And the swap chain sort of takes care of showing one of these in turn on the screen. So that's essentially like your back buffer, if you're used to that term, or frame buffer, if you're used to like Vulkan or OpenGL terminology. So the way we do this in Basis is swap chain has a special render target. So it has a render target 2, and swap chain sort of creates that render target, and the render target then kind of points to all of these in turn, if you will. It's special in that sense. The device creates the swap chain just like it creates everything else, but in this case the swap chain is sort of responsible for actually creating the render target like this. You can still create other render targets, like these other ones, if you want to like render like off-screen buffers. But this is essentially the way it's set up. Right. So what we'll want to do now is make sure that we can create our swap chain, and the swap chain creates a render target. And the render target then sets up everything needed to actually have these images backed by, or have the swap chain backed by the images. And that's supposed to be pretty easy with VEZ. It's quite complicated with normal Vulkan to do, if I remember correctly. And while we're at it, we might as well actually create this standard render target logic as well, because it's supposed to be pretty simple with VEZ again. And if we have that covered, then we essentially have the whole render target system done. We don't have to care about those anymore. So I think this part will be all about render targets and swap chains. Okay, so we have here a class for the swap chain, which, like every other GFX API object, derives from the interface. And here you can see that it's actually called getNextRenderTarget. So if you have these images here, you're supposed to essentially not really have to care which one you're rendering to, but you can ask the swap chain, hey, give me the render target that represents the next image in this chain, and then it just goes from this to this to this, back to this, and so on. And you can get some height and width, apparently. That's it, essentially. That's what the swap chain looks like to the engine. But depending on the actual graphics API, it may or may not be pretty complicated underneath. Right, so my next question would be, do we actually create a swap chain? So do we actually reach this function? And yes, we do. So in the renderer init internal, we set up a swap chain description. We give it the depth buffer format to use, and we create the swap chain. Okay, that's good. That's good. So we should make sure now that the backend actually creates something then to render onto. And this is where the surface comes in, which we created earlier. So we don't have this yet, but I have this commented out here. We could actually just uncomment it now and then proceed to actually create it. So we'll actually probably, yeah, we get the device here. So let's hold on to that. That's the first thing we'll want to do. So render device VK, what do we call this? It's like device VK. Yeah. And we'll want the render window. So this will be again the fully qualified one. So the GLFWVK, it's kind of a mouthful to say. Render window. And we'll want the surface. What was the type name of the surface? Hello. Oh, there we go. So it's VK surface KHR. Yeah. Like this. And then we'll want a new type, which is called VEZ swap chain. Yeah, and that should be like a handle type again. And then we'll want to actually have a member for the render target. So let's create one for that. And I think in this case, because VEZ does apparently, or shall we say, according to the documentation, VEZ does a very nice job of just abstracting all of the complexities of the swap chain away from us. I think we should be fine with just one render target. Sometimes you have to have multiple of these and manage them directly, but I think in this case we can just return like the one and only render target. We'll see if it works out. But let's init these guys. So device, and then render window is null. Surface, this would be vk null null handle. Swap chain probably as well. Render target at this point is still null, and the description we actually, yeah, we should create that function that we're actually already calling here. So init. So it would be, looking at the how we call it, it would be render window like this, and then vk surface, that's surface, and then finally the actual swap chain description, which we'll get from the game or the engine, like so, and then we can just hold on to those guys. That's where we want to go. So let's add it here. Right. So I think this is the only thing we'll actually want to do here, is just get the render window, get the surface, and get the description. That's probably it. Oh, like so. Right. Right. I'm looking at this create and destroy here. This looks like a place where we might want to actually wait for the device. So Vulkan has this function called, what is it? Something idle. Device idle. Wait idle. Yes, here we go. So device VK, and we'll want to get the VK device out of it. This looks a bit silly because this is a render device VK, and this is a VK device. That is how it looks. So whenever you resize the window, which happens if someone resizes the window, and this gets called because the swap chain is a render window listener, and this gets added as a listener for the window, which we may or may not have to actually do ourselves here. I think we might have to do that. But anyway, this gets called. We need to destroy probably the swap chain. At least this is how it was in Metal, and I'm thinking that's probably how it is in Vulkan as well. Typically in these cases it's a good idea to wait for the device to become idle before you destroy things. So I'm just going to put that there. It shouldn't really make it worse. At least it's sort of, it's a bit safer to have it there. Yeah, the synchronization is something that's a bit tricky with Vulkan to get right. I'm sure I'm not going to get it right in this video series, not having used Vulkan for a pretty long time. But yeah, it's something that I'm going to have to get right eventually. Anyway, so the way we actually create this thing, if we go back to the device and look at this, so we create the actual swap chain, then we call init on it, and then we call add reference, and add reference actually calls create. Release then calls destroy, but once the first reference has been added, create is called. So that means that we get this gets called, init gets called, and then create gets called. So at this point, the render window will have been set. So I'm gonna add the listener here. Then we have, I think, back buffer width, and this comes from like the base class. This is what we looked at earlier. I remember seeing these two here. So let's just get them there. I think we should get those from the window probably. No, come on. Yeah. Just do that, and just to make sure that it's actually updated correctly. Because obviously if we resize the window, we call destroy and then create, and this gets called again, and this gets set again, or updated, shall we say. Alright, so then we create the swap chain. How do we create the swap chain? Let's have a look at the, not that, the EZ. So queue submission, we haven't gotten that far yet. Can we? There we go, swap chain. Okay. So. Right, so we fill in the format that we want, the color space, non-linear sRGB, yeah, that's probably what we want. Okay. And then we get the VK, no, like, yeah, we get the Viz swap chain out of that. Okay. Okay. Let's start by doing this essentially, and then seeing what that guy has eaten. So we do this, and we add it here. So surface, yeah, that is something that we have, so we can give it the surface format. So it has the VK format and the color space. Okay. And the device has this get back buffer format thingy, which is used for all the backends, so we can use that here. Swap chain, create info format, and this would be then get format, right? Yes. And that would be device VK, get back buffer format, and then VK, what was it, color space, sRGB, non-linear. Is that the right one? Let's have a look. Let's have a look. Yeah, that is the one they used at least, so let's use that as well. Triple buffer, that we want. I don't know why they don't. Let's set it to VK true. I don't know why they don't have that in the docs, but we do want that. VK result. Result is VEZ create swap chain. Okay. That's the device, so we do device get VK device, and this would be the address of that guy, and this would be the address of swap chain, right? Something like that. Basis assert f result should be VK success. Like so. And that's probably fine. And right, device VK. We have the render target is the last thing that we have, and we have this here already. If we follow the same format as metal, it would look like this. So let's assume it will and just add it here. So it would be mRender target equals mDevice VK create swap chain render target, and width would be the back buffer width, and that would be the back buffer height, and swap chain is it's this, and depth buffer format that was passed yes in the description. Yeah. So some of these things, they kind of like just feel like, oh, I just have them all handily at hand. But that is of course because I tend to follow the same patterns as I have for the two other backends. So I just know that this is how I created on those. And so it just happens to, everything falls into place, so to speak. Okay, let's do the destruction so that we don't forget to do that. So render window, remove listener would be this, and then we need to probably, yeah, that should be the last one, shouldn't it? I think that should be the last one. So render target, we just release the render target, and we can set it to null. And then in between them, we do VEZ destroy swap chain. No, yes, swap chain is there. Okay. And mDevice VK get VK device and mSwap chain, and mSwap chain is VK null handle, right? Yeah. Create swap chain, destroy swap chain. Yeah. Typically, if there is a VEZ create something, there is also a VEZ destroy something. Same thing with the raw Vulkan calls. If there is a VK create something, there's typically a VK destroy the same thing, essentially. All right, let's see if we can get a swap chain going. All right, what do we have? Right, we have full HD resolution. Looks good, and yes, success. Nice. And here we actually go in. We don't do anything with the render target yet, so that's the next class to actually do. And we're still crashing in the same place, and we're gonna keep doing that for some time still. But nice. This looks pretty done to me. This, maybe there's gonna be something more, but yeah, I think we're done with this, and we can move on to the render target. Okay, so for the render targets, let's have a look at this again. Render targets in Vulkan are called frame buffers, I think. Okay. In Vulkan, an application must specify an array of VK image attachments, compatible render pass, dimension, blah blah blah. VC implements this to only requiring the array of attachments and the dimensions. Render pass is never explicitly created. Okay. Right. Yes. So we create the images. VEZ create image. And then we create an image view to it. And then we create the depth image and an image view to that. And then the frame buffer. Okay. Okay, that sounds pretty much exactly like what we want in our render target class. Okay. We can maybe copy paste that, but let's not do it yet. Let's have a look at the render target class first. And like I mentioned with... okay, that's... Screen share is no longer active. Okay, let's see if I can fix this. See if I can fix it and make it active. Oh. Right, here we go. Right, so yes, we essentially have render passes in two different forms. We have the render targets. We have the render targets that are created directly on the device, like these guys here. They're backed by another image, an image which is also, I should add, created on the device. So there are arrows going from the device to those guys as well. And then we have this render target here, this special one, which is owned and created and managed by the swap chain here. And you essentially just want to create a swap chain, which we already do, and you want the swap chain to create a render target, and you want the whole thing to be sort of packaged together, and you want there to be some images for you to render to. Now the reason why we do it like this is that if you have any code at all and you want to start rendering somewhere, you actually just want to give it a render target. And the code should look exactly the same whether you're rendering to this render target or to this render target. You don't want that code to really have to even care or know, is this going to go to the back buffer or to this off-screen image here. It's just a render target, and that's why I've set it up so the swap chain creates render targets that essentially look completely similar to these render targets here, but this one is a very special one. So I think we'll start with the special one actually. So if we go to render target.h, you can see what the code fills in when it actually creates a normal render target. So it creates a render target description, it puts some attachments into the description, and there's some convenience method as well. And for each attachment, it specifies the type, which is one of these guys, a texture, which is the backing image, an array into a texture array, if it is a texture array, and then the format to actually treat it as. And then you give one of these guys to the device, and it gives you back a render target. So that's good and all. But if you create a swap chain and it should create a render target for you, then it looks a bit different. Then the swap chain create goes to the device and tells it create swap chain render target, and it just gives it the size, the actual pointer to this guy, and the depth buffer format. And the device creates a render target in the normal way, but it actually calls init as swap chain RT, as opposed to where's the normal one? Create render target is here. As opposed to the normal one, which just calls init, right? And init, what does init do? Yeah, it just stores the description, And if this is called, we don't even get a description, we just get all these guys. But we should be fine with those, because the other backends are fine with that. Okay. Okay. So what do we do? Well, let's at least start by storing the info that we get. We get the width. So we store it in mWidth, and you can see we have some of these members here in the base class. So let's do that. Is swap chain render target is definitely something that we'll want to actually set here. So let's do that. Oh, and I would guess actually that that we would want to init this to false. Except we can't really do it. What? What? Why can't we do it? Is it because this guy is already... It's setting it to false, so there's no point in doing that, but I still think I should be able to do that. But okay, maybe not. Okay. Anyway. Alright, you can't actually init members in like a base class. Yeah, that's probably true. Yeah, anyway, we don't need to do it because it's done there already, so that's fine. Yeah, here I have a define, which is just basically copy-pasted from Metal. So we have a number of max color attachments. I think I can leave this here for now. Like no one's gonna want to create a render target with more than 8 color attachments anyway. So we don't have to have like a lot of dynamic lists here, like vectors and stuff. We can just have fixed size arrays. That's why this guy is here. Let's leave it like that for now. But what we actually want to have though is, first of all, a VK, and not VK. What was it called? We render device VK. So device VK, and we'll hold on to that. And we're passing it to the base class, but it can't refer to a render device VK. It can only refer to a render device, because this is again not aware of any Vulkan things. So that's why we keep a separate one, which is like the fully qualified, if you will, name of it. Okay, so like we looked at in the documentation, we want images and we want image views. So let's create some lists now for those. So we want VK image. This would be mcolor attachments. Hello, color attachment images, right? And now we can use this guy here to just have some fixed size lists. And we need views to all of them. And we want the format. Format was one thing. I think it can be probably a VK format. Color attachment format. Kind of like that. And then we, of course, we need something to keep track of how many of them are actually sort of active. And then for the depth side, we can't have more than one, so we can just have a depth stencil image and VK image view mdepth stencil image view, right? And format again. That stencil stencil format probably. And then whether or not we have a depth stencil as depth stencil attachment. Like here is not a question of how many, it's a question of do we have one or do we not have one. Because you can create frame buffers without depth attachments. Let's look quickly at what this looks like in Metal. So in Metal we have something slightly similar. Okay, I bundled it into color, into like structs here. Yeah, but it's essentially the same. We have a vector here. Okay, and we have a depth attachment, and then we have a bool to tell if that's actually valid. Yeah. I don't know. I think we'll want to actually feed these as like arrays into some Vulkan function when we bind these. So that's why I kept them in as like separate. I think this one in particular we want to actually give as like an array. I may be wrong. We'll see. This will do for now. Okay, and and what then? Then we want like the frame buffer thingy, and what was that like? What was that? What was that? So we use. It's a Vez frame buffer that we are creating out of all of this, right? Okay, so let's have a Vez frame buffer here. Frame buffer. Is it just like this? Frame buffer handle something. Right. And is that it? I think that might be it. And that would be a VK null handle, but I think we have more things to initialize properly. We have the count, which should be initialized to 0. We have the boolean, which should be initialized to false. And do we have something else? I think that's probably what we want. Okay, so now we can continue with the init as swap chain RT, because now we have somewhere to actually store these things. So what do we start with? Like if we're using it as a swap chain RT, I guess for now at least we can assume we have one color attachment and one depth stencil attachment, right? So let's maybe set this to 1 and depth has depth stencil to true. Let's just assume that's the case for now. Right, what do we need to do then? And we can set the format immediately. Formats for the first one, that would be get format. Device VK get back buffer format. This get format thingy, this is what we looked at earlier, by the way. If you see like a method that I'm using called get something, that's probably part of this conversion code. So get format, get primitive topology, patch control point, get fill mode, get call mode, get stencil up, all of these things, conversions between or from basis types into Vulkan types in this case. Right, and the depth stencil format we actually get as a perimeter. So again, get format, depth stencil format. Right. Right. Okay, and now we can maybe copy paste this whole thing from the like this thing. And see where that leaves us. I have some annoying line numbers here. Let's try to get rid of those without breaking everything. Can I do that, please? Can I do that, please? Okay. Okay, what do we have? Image create info. Okay. Format is supposed to be this guy. Like if we go through these in order. Image type is 2D, yeah, that's fine. Format is this. Width and height, actually, yeah, they match those completely. Maps and layers are 1. Samples, yeah, we don't use any multi-sampling, so that's fine. Tiling optimal, I think you have to actually use that, yeah. Transfer bit, color attachment bit. I'm not sure about these, but they use these in the docs. So let's actually do the same. And we don't want that, and we don't want this. We want VK device, VK get, VK device. Again, it's a bit silly. GPU only memory is probably exactly what we want. I do want the VK result here though, so that we can again error out if, or give the developer, or in this case us, a warning if it fails, like so. And we of course want to do color images 0. Store in the first color image. Right, and then we can take this guy and feed it into the next phase. So the next phase is creating the image view, and we give the image that we just created. The image view is that. The format is probably the same as we did previously. Yes, the format exactly. Layer count and level count, that's fine. Again, we get rid of that. And we put the result there. Actually, we can put the result in front of all of these calls. We'll want the result. Oh, but we can't redefine it. Just reuse it. That's what we want. And then I can put the device here as well, in front of everything. So yeah, and here we want image views 0, right? So that's that. And then, yeah, we don't actually even need to check if we have a depth stencil anything, because we do, because we said we would have it. True. Yes. Okay, good. I'm just gonna rename these to their proper names, like so. Okay, so depth stencil image is that one. Put that there, and we feed it to the next phase. And again, we check the parameters. So type 2D is fine. Format is probably fine. Actually, no, that's not correct. It's supposed to be that one, right? Yeah. That looks good. Usage, yeah, that's probably fine as well. Right. Yeah, image 1 and 1, and that's good, and we don't want that, but instead we want that, and that's good. Actually, let's just leave a bit of space between those. Okay, and then finally, we can actually create the frame buffer. And we want the image view. Yes, the image view. So we want that one, and we want this one. And attachment count. That is correct. It is always 2, but whatever. What? Depth? That's not... Oh, their docs are wrong. It's not called depth, it's called layers. And the frame buffer handle is not that, but it is the frame buffer handle, which we add there. Like so. Okay. And we're gonna run this in a second, but let's actually destroy them, right? Should we destroy them? The destruction is a bit more complicated in this class, because if we're not a swap chain render target, then we don't want to actually destroy these images because we haven't created them. They've come in through the render target description. So we actually want to be a bit careful here. Let's see. If we have a frame buffer handle, if this is not a null handle, then we can do VEZ. I would assume there is a destroy frame buffer, and there is. Good. And we can do device VK, get VK device, and do this, and then set it to null. And that is always going to be the case. But now we want to have slightly different logic if we are a swap chain render target versus a normal one. So I'm just gonna put a to do here for the normal case, and we can essentially here we can undo everything we did here. Right, so even though we always create one, we can put this in a for loop. So color attachment count, and we can do VEZ, destroy, I guess, image view first. And this would be, well, that's the same freaking thing. Let's get this. I'm gonna need that device a lot, so let's just do VK device. It's like device VK get device. We can just use this all over the place. Same color, attachment views, not 0 but I, like so, and then we create the actual image as well, and then we set the count to 0, and then similarly we do have a stencil account here, but since we did it in a for loop, we can do it in an if statement here and just do essentially the same thing here, but we do this instead, and we do this instead, and then we set this to false. Right? So now we're undoing what we do up there, right? And in create, I don't think we really want to do anything in create unless we are a normal one. So if not is swap chain, like this is where we want to hook up those normal ones that we're given, the normal images. But in it as swap chain RT, this just does everything, if that makes sense. I hope it makes sense. Yeah. Yeah, we might actually not even be able to do the normal part yet, not until we have textures working and implemented. But we should be able to do this. We should be able to run this. So let's give it a go. See if it builds first of all. And it seems to build, and we can run it. And what do we have? Do we have some sensible data coming in? Yep, that looks good. Looks good. Okay, we create a back buffer for us. Success, good. This is going almost surprisingly well so far. Why? When is it gonna actually break? Well, not here. That's for sure. Okay, cool. Okay, now we have the render target for our swap chain. That's awesome. That is awesome. So now if we go here and we go to here and we go to, where do we go? What? Why is this thing not listing the color attachments? That's strange. What if I add a watch to it? Huh. All right, it's because, right, it's, yeah, the render target. Here we go. Yeah, it's just me being silly. So right, we have one attachment, color attachment count. We do have an image which has some value. That's good. Okay, okay. Yeah, the other ones have some sort of debug pattern. Okay. Excellent. Excellent. Cool. That means that we might want to actually move on to another class for the time being and come back to render target later for the sort of normal render target case. Because again, if we look at render target here, we get essentially a vector. Like this render target description is essentially a vector of attachments and some convenience methods. And a render target attachment is essentially a pointer to a texture with some metadata. And of course, we haven't implemented any textures yet, so we don't really know what to do with these guys if we get a vector of them. We don't really know anything at all. So maybe texture is the next step. Implementing texture VK. Like we have this thing and it's an empty gaping hole, essentially. It has nothing in it. Yeah. I think texture is next on our list, and we will start tackling that next time. So, as usual, hit all the like buttons, like all the videos, do all the things, and I'll see you next time. Bye.